I'm writing the equation again. What we can say is, I can say VSG equals to minus VI upon 1 plus GM into RS. So that is the point where we usually tend to do the mistake and we ran into trouble. So your output voltage VO is GM VSG into RD. VSG into RD. Substituting this VSG over here, you will get VO equals to minus GM into RD upon 1 plus GM into RS. This multiplied by VI. So when it is going on the other side, you will get VO by VI equals to minus GM into RD upon 1 plus GM into RS. Now this value they have given it as minus 3. Right, so from this you know the value of GM. So when you are substituting, you have got it as 2.83 milliampere per volt. GM we have got it as 2.83 milliampere per volt. So when you substitute in this equation, you will get 3 equals to 2.83 into 10 raised to minus 3 RD upon 1 plus 2.83 into 10 raised to minus 3 into RS. So when you solve this equation and you have got R1 plus R2, you have already got RS plus RD as 3.125 kilo ohms. 3.125 kilo ohms. This is equation 1. So when you solve equation 1 and 2, you will get the value of RS as 0.345 kilo ohms and you will get the value of RD as 2.78 kilo ohms. This is, we have solved the problem. Now coming to the next part. Now we know the value of RS and RD. Now we'll go for the finding of R1 and R2. Now you know that we can find the gate voltage VG as R2 upon R1 plus R2 into VDD by potential divider rule. Now in this, VDD is given as 20 and R1 plus R2 is given as 400k in the question. So what we can say, VG equals to 20 upon 400 kilo ohms into R2. Call this as equation number 3. Now looking at the diagram, you have RS over here and this is your source, this is your plus VDD and the current flowing through RS is ID. So when you apply KVL in this loop, your equation will be, you can say KVL to source loop, your equation will be VDD minus ID into RS minus Vs equals to 0. So from this we can calculate Vs as VDD minus ID into RS. So this will give you the value of Vs as 18.6 volts. Why? VDD is given as 20, ID is given as 4 milliamperes and RS we have found it as 0.345 kilo ohms. Now in this question, if you make a mistake while finding the value of RS or the value of RD, the error will propagate and the entire question will be wrong. So it is very important to find the values of RS and RD very correctly. If the value of RS is wrong, you will get the value of Vs wrong and the error will propagate. Similarly, we can find the gate voltage. You know VGS or VSG we can call. In this case, if you are calling VGS, it will be VG minus Vs, right? Or we can say if it is P channel, we are writing in N channel. In P channel, we write it as VSG equals to Vs minus Vg. So from this formula, we can find the value of Vg, that is the gate voltage. If it is DC analysis, if you are writing it as capital, so it will be Vg more than one and the same. So Vg you will get it as 17.4 volts. You know the value of voltage at the source and VSG we have already found out. So from this you will get Vg as 17.4. Now if this value you substitute in equation number 3, substitute 4 in 3, that is this equation, this will give you the value of R2. So therefore we can write the value of R2, you will get it as 348 kilo ohms. Now how it is solved, you know Vg we have got as 17.4 equals to 20 upon 400 kilo ohms into R2. So this will give you the value of R2 as 348 kilo ohms. So once you know the value of R2, you can find the value of R1, which will be 52 kilo ohms. How to find out? The total of R1 and R2 is given as 400 kilo ohms. So from 400 kilo ohms, if I subtract 348 kilo ohms, I will get it as 52 kilo ohms. This is how it is solved, right? Thank you for watching in 5 minutes.